Welcome, my name is Christopher Johnson with mediaworkstations.net, and we are here at SIGGRAPH 2013 to speak about the state of the union in 3D graphics and feature film. And with me today are Jules Urbach, the CEO of Otoy, Wil Braithwaite of nVidia, he is a senior visual effects engineer with nVidia, and Billy Brooks, a veteran special effects artist. What I want to do today is I want to start with you, Billy, and really ground the conversation in feature film. First off, take a look at, you have a 20-year career, and you've done, films, everything from Star Wars to Men in Black to X2 to the current Space Station 76. And what I'd like you to do is fill us in on, in your workflow, in your day-to-day work, what's working and what's not working?
What is working is I am using Octane as my render engine for the show. Very excited about it. I'm in the process of setting up textures and stuff to work into Octane because you have to reconfigure them to work with the render engine, as you do most render engines. And I love how it's just coming together. I mean, it just works, and you're going to see this whole like, oh my God, I'm so excited kind of thing because I'm so excited to be an artist again. Just to be able to iterate effortlessly. I was thinking driving down here that sometimes technology is a bottleneck to creativity, and I'm not feeling that too much on the show, and I have these guys to thank because it's a dream come true for me.
I think that's really interesting because I like the idea that, you remember back in the old days when we used to have these big SGI fridge-like machines with big onyxes and stuff like that, and they were so impressive and you could sort of stack up the graphics processing in, and they were very scalable machines. And that's what the Inferno suites and the Flame suites and things were built on, and you have the client sitting behind you asking for all kinds of bizarre drinks for the runners to go and get them. But you'd be there like with your tablet, working away super fast, really quick. And the idea of sort of processing something or sending it off to a farm was a bit foreign. You do it locally. And we've sort of come back to that now, or the opportunity has come back to that. We now have as much power in a workstation with a couple GPUs in it, if not more power, than we used to have in that giant fridge. So we sort of stepped away from Infernos and things and moved into node-based compositing and slightly more contrived workflows. They're very powerful tools, but they, from an artist's perspective, they break the flow, the organic nature of art, of experimentation. And you can't interact with what you're getting. You have to sort of set up this thing, you have to know what you're going to get in the end. You process the whole thing and you go, okay, that was a little wrong. What nodes do I need to tweak? But now we can just sort of mess about with it on the fly. And tools like Octane and artists like Billy are sort of, bringing that Inferno experience back to art, which I think is more creative. I mean, they both have their place, obviously. But personally, I prefer the... Do you remember that old TV show where it was, Happy Accidents? The painting guy?
Oh yeah.
So, Happy Accidents. You can only get that with interactive tools.
It's usually unhappy accidents, the old school way.
And you had to wait ages to find out that it was an accident.
Yeah.
I mean, the reason why we're so excited about Octane, and the reason we've kept it at GPU render is to really provide that kind of speed and that iterative feedback that you get from just being able to see almost a final render as you're moving the lights around and changing the scene. So there is a place for having Octane just in a workstation, and of course we are getting our toes wet with the cloud service as well. But what we're finding is that I think for most scenes, you can, even just with a couple of GPUs, you can do a lot. And it's just when you're doing final render, I mean, the cloud service allows us to go all the way to 8K and to do that in stereo and to do it instantly, and that's pretty cool on demand. But there's for an artist working in a scene, I mean, I think what we have even just with a couple of high-end graphics cards is already really impressive. So we're excited to see that develop, and the roadmap that nVidia's laid out with the power going down, I guess, significantly every generation, as we've seen with Kepler from Fermi, just means you'll have double the rendering power in the workstation almost with every new card that comes out every year, and that's been pretty amazing.
Specifically coming back to Octane Render, which is kind of the mega hot platform these days. What are you finding that's working and not working? Like, in other words, what have been your big breakthroughs or successes in the last year or two, and what are you still coming up against?
Well, I think the biggest breakthrough that we showed actually at GTC about in March was that we have a new way of calculating all the acceleration structures. So you can now, inside of the plugins or in Octane itself, you can move things around, you can deform objects, and the voxelization step is much faster. And that's something that we're continuously improving on. So even at SIGGRAPH today, we're showing that in our other engine brigade, which has a lot of the shared code with Octane, we can now move characters around fluidly, 60 frames a second. And that's been a big breakthrough. A lot of times, when we started with Octane, it was really about static scenes and rendering those nicely. Now we're moving more towards dynamic scenes. As we get into newer versions of Octane, we're going to be working on things like displacement and motion blur, particles, strands. Those are on our roadmap. And I think that for right now, we're just interested in just making sure that that all the features that we have work really well and are as dynamic as possible. That is the other sort of revelation, I think, to artists, is when you can actually get all that speed and flexibility, but also deform scenes and use it in projects potentially as diverse as Motion Builder, right? With mocap, that could be pretty exciting. So we're very focused on that.
60 frames per second.
Science fiction, man.
Yeah, it's
game engine soon.
That's exactly, well, that's the thing. We are doing a game engine based on this kind of technology, and we split it. Octane is for high-end rendering, Brigade has been for games, and there's a little bit of shared code. But yeah, they're going to be both supporting the games industry and the films industry with a sort of shared API code base.
There's this perennial question, and maybe you can frame it first by describing the difference between G-Force and Quadro. I know it's as old as
it had to come up. Every conference.
Everybody.
I just didn't think it would be on camera.
So first, if you could frame it by saying,
sure,
this is G-Force, this is Quadro.
Sure.
Here's
a good way to think about G-Force and Quadro. I mean, there are some subtle architectural differences between the two, and more importantly, when I say between the two, if you took an identical chip architecture and one was a Quadro and one was a G-Force, there would be some subtle differences at the hardware level. But what's more important is what's at the software level in the driver and the support. It's like sort of, you look at a Volkswagen car, it's going to share components with the Audi. And the Audi is a much better experience. You pay a lot more money for it. You get a lot better support. It's a lot smoother ride. It doesn't break down as much, perhaps. I mean, I don't know if these things are technically true. Maybe I should take other companies off the table for a second. But it's kind of like that. So the G-Force, a lot of the time we don't make the G-Forces. We just provide the chip and some kind of spec guideline. Other people will make them. We make the Quadros. So we guarantee the Quadros. If anything breaks down the Quadro, we'll send you another one, that kind of thing. So professional customers would always gravitate towards Quadro. Plus the drivers are certified with all the main applications that you typically use, so like Autodesk Maya or Max or any of those things are completely tested and certified. Whereas on the G-Force side, it's only games that go through that part, the AAA games and things. So there's a huge difference there. And then there are some subtle hardware differences. Things like copy engine support, asynchronous engine support, which we find that professional applications use a lot more. Multi-threading support.
double point precision.
Double precision, though double precision now is on the higher end GeForce cards.
Yeah.
Less important for visual effects customers, we think. Most things in the visual effects world, almost everything, except for a few crazy matrix solves or something, might be, almost everything is 32-bit precision. But it's also memory sizes and things like that. Because it's professional customers, the Quadro cards will put more memory on them. So they are more expensive for a sort of multitude of reasons. I think it's valid. I actually really think it's valid.
What we're seeing with a lot of customers in Octane is they'll have Quadro card as their main display card, and then they'll buy a Titan for rendering with Octane, and then they'll buy a second Titan for rendering with Octane. So you've got 4 slots. But for the main display card, a lot of people are using the Quadros. And Octane doesn't seem to run as well on those relative to the price you're paying as the consumer cards, but generally the mix of both of them is actually, we're seeing a lot of that in professional studios. So I guess both have their place.
Billy, you can speak to this too, because we at Media Workstations, we swapped out your GTX 690 for the Titan, and you were like,
I was very happy.
Very happy. Yeah,
Titan's amazing. Octane runs amazing on the Titan.
Yeah, I was
the Titan
very excited.
is an incredible card, and actually it's
straddles both worlds in a way, right?
It does exactly do that because we actually manufacture the Titan. We manufacture the flagship G-Forces, so those are done with the same level of quality as the Quadros, but without the software support and the well, there is technical support with that because we make it. But the lower end, when people say what's the difference between GeForce and Quadro, they're usually talking about what's the difference between some splashy box with some sexy girl on the front, and what's the difference between the nice slick black box you get from nVidia that says Quadro on it, you know, that kind of thing. And it's mostly a support issue. Another thing is, if you buy Quadro and you're a professional customer, you get people like me coming to your studio offering to help you code things. So there's a relationship.
Nice.
It's like, you live in LA? Oh. But GeForce, you certainly wouldn't get that. Different kind of customer, different demographic.
Exactly. Yeah.
But the flagship GeForces are absolutely worth a look in, for sure. I mean, the 690 was rather fancy too, because it had the Gemini chipset. It was the first, well, the K10 was the first, was on professional side. The Tesla K10 had 2 chips on one board, which means that you get incredibly fast PCI Gen 3 connection between the two, completely unhindered by what the CPU or the bus is doing. So it's like 12 gigabytes a second between. So if you're doing like fluid dynamics or something, or ray tracing is a good example, something where, or potentially something you might need to share the data a little more often. Ray tracing, you can get away with not sharing the data quite so well. But fluid dynamics, you need to share those edge cases and things like that. Having 2 GPUs working together on their own PCI switch, being able to incredibly fast borrow data from each other, sort of expands how much memory you have on the card. You can imagine the future. What if you had like 2 24 gig chips, you know, like right next to each other, just sharing data?
Yeah.
48 gigs or something like that.
What is happening in terms of like software packages lining up behind a certain graphics platform, or not lining up at all and sticking with, like ZBrush, for example? You aren't benefited at all by having any type of video card. It's all like, you know, CPU-based processing still. Is there anything happening on that front? Are you guys involved in conversations?
I think it's entirely up to the ISVs, isn't it? Whether or not they decide to leverage the technology platforms that are out there. I mean, you know, Maya as a DCC app has a fair chunk of graphics work in it, yet you don't see much CUDA simulation stuff in there. You don't see much on the simulation side. They're using CPU for all their simulation work, but they're using the GPU and OpenGL heavily for all their rendering of Viewpoint 2.0, which, you know, came out quite relatively recently, giving you fancy graphics and shaders and things at the viewport and subdivision surfaces and hair filaments and so forth. So they are, you know, and texture, of course. The GPU is heavily utilized on that side, but it won't be on the other side because it was built a long time ago. It's got a lot of older code that they need to support and integrate with maybe newer particle systems or fluid dynamic systems that they have. So if they were to write, you know, one bit of it to be super accelerated, it wouldn't necessarily fit well into the pipeline of the rest of their architecture. But what we see is a lot of smaller companies that are sort of approaching a problem fresh. You know, I don't want to say Octane is a small, Otoy is a smaller company, but it's certainly got a fresh perspective on the problem. Gets to, you sort of go, okay, how are we going to do this, thinking about the future? So I think we see that a lot. We see the newer companies thinking about how to do this, whether it's OpenCL or CUDA or just, you know, OpenGL Compute or something.
Yeah. Well, you know, we wrote our, you know, we're a CUDA company. Obviously, Octane is written entirely in CUDA, but we also have, and you know, and you guys helped us build this. We have an OpenCL compiler that we built on the CUDA driver, and so that was so that we could have both. You know, so you could be able to write extensions potentially to Octane Online in OpenCL, but it would run with the CUDA, you know, code that we already have. And yeah, we were a GPU company, and then the whole benefit of Octane was that a lot of people, until Octane showed up, were like, hard to do unbiased rendering on a GPU, ray tracing even, and so, you know, that sort of, it blew the lid on all that. And the only real resistance we've seen on the movie side of things is, well, we need more memory, right? So thank God when you guys came up with the 6 gig cards, that helped. I don't know if you guys are ready to announce what comes next, but you know, that should be. But you know, it seems like you know, down the line there's going to be even more memory, and then down the line even more. So you know, you're talking hypothetically, you know, 48 gigs in one card. That's enough to do pretty much anything at that point.
There's a sort of sweet spot of about 32 gigs, isn't there? Yeah. You have that. You can pretty much do production scenes that are out there at the moment. And,
that's the first thing that happened to me, is that I was playing with it and I'm like, you know, just sort of lost in a tunnel of love with this, whole experience. And so I just found out when that's right,
One way of
that's right.
putting it.
I'll marry it when it's legal.
You two like to sit together.
Yeah, you're getting in the way of our relationship. I'm sorry.
So for me, when I started getting the real models in there, in the real textures, and I immediately ran out of memory because I had the 690 that had the maxed out at 2 gigs per processor, right? But I looked at it and I heard about the Titan. I'm like, well, that obviously would, that's the best I can get, for my budget right now. So I did it and immediately solved the problem. But still 6 gigs. When we started getting, more models and more textures and start beefing it up, it's potential we'll run out of memory again. But I'm not at that point right now for this project at least. So, the 6 gigs totally solved a lot of problems for me.
Yeah.
Well, I think that, obviously I can't say anything on this public platform about, what's going to come out when.
You could.
But I absolutely couldn't do my neck. But it's inevitable. You've seen with every, as the products come out, certainly every generation, every 2 years we have generation, we do our product lineup. The memory size always pretty much doubles.
Yeah.
It just sort of doubles all the way up. And we're approaching that point where we, you can see we've got our range of models from the sort of, the GeForces come out first typically because, we hit the gaming market first, and then the mid-range Quadro, sort of sweet spot Quadro would come out. This is sort of the most bang for your buck, and then the lower end ones, and then the super higher end one. And so that's going to happen at some point before our next generation architecture in 2014 would come out, the Maxwell architecture.
Maxwell's very exciting. I think that's going to be an amazing chip. I mean, it's what you guys already have is amazing. And as far as the memory goes, I mean, if you were to imagine, let's say, a Titan with or the equivalent of that with 12 gigs, hypothetically speaking, that's enough to really load a good chunk of what you'd want to do in a lot of shots and a lot of movies. And I'd say if you're going by that formula, then the next iteration, I think 24 gigs, and then if you put 2 of those in a card, you're good. And we're also looking at various things like compressing textures and things like that. I mean, that's GPUs are very fast. There's a lot of interesting hardware coming out in Maxwell. You guys will support hardware compressed textures, I think, in that at some point, or maybe that's on the horizon. So I think that there are things that we're looking at that'll even make the extra memory work even better. And of course, I think there's always the ability of doing out-of-core rendering, which would slow Octane down, but it's always an option if we really needed to use all of that memory. There are ways of doing that, and there's papers on that. We looked at doing it. We want to kind of keep Octane as fast as possible and work within GPU memory, and especially I think as the memory keeps increasing, we're in pretty good shape. So we'll see what productions needs. But I mean, I think that when you're getting into the 12 gig, 48 gig, all that stuff, you're in fantastic shape. And also things like fire and fluid simulation, you can't split that up among many cards, and so we're looking at doing that for potential dynamics in Octane down the line.
That brings up another point too, this question of cloud versus not cloud, and what kind of dynamic you're experiencing in terms of like your client base. Like Billy is working with a classic workstation, and what are you finding like in terms of the customer dynamic and feedback and what's happening on that front?
I think that for anything short of final render, customers now have enough. They can put 8 GeForces in one box if they want to have that in their office. That is an option if they really want to have that rendering power. One Titan. One Titan in a machine is almost plenty to get a real-time viewport that's really good. What the cloud does, it'll give you a noise-free render instantly, and it'll give you that at 8K. And so therefore, when you're, if you're doing a movie like Fantastic Four or some of the other projects that we're now involved in on the film side of things, that cloud service is, is really, really useful because it will give you, a final finished movie very quickly. And it's also very useful when you have really torturous rendering scenes where you've got a lot of glass or mist or something like that, where there's scattering and you're turning path tracing on. The cloud service of Octane will be able to, chomp through that 100, 200 times faster than, one card. So, and having that available on demand is important. So we've been focused mostly with high-end customers that need that for those films, but the idea is that rolls out and becomes a service that any Octane customer can use once they sort of tapped out what they can do or want to do on their own local machine. And so the workflow is really, I feel that, and I feel the cloud service is much more useful for final render. Or if you're willing to spend the money, you can get a 4K final render, in real time off the cloud service as well. But it's more expensive, and that's a luxury that you probably don't need as an artist if you have a couple of really good GPUs on your workstation, especially the modern ones, right?
For me, I've been in a lot of places, different studios that just because of developing technology, that the feedback interactively is not as good as an artist would love, obviously. But that's my joy, is being able to see pretty much what I'm going to get if I was to go to a render farm or like a cloud-based services. But working interactively, I know what I'm going to get. There's no surprises. That's always the thing. You come in the next morning, from an overnight render at a studio, and it's like, okay, am I going to have a good day or not, right? And because the interactivity sometimes does not match what you're going to get back from the render farm.
Try
right?
fluid dynamics.
Yeah.
It's even worse.
Dude, I'm right there with you. So it's like, that's the joy that I'm experiencing, like last night, is that I'm able to see exactly what I'm going to get, and I can trust it because it's always the same. It's like that's the one gift about this whole experience for me, is like what you see is what you get. Especially if not having to let it run to get rid of the noise, but if you had to be able to send it off to a cloud service, get it back, and the noise free, and there's no surprises because you've already seen what you're going to get. I mean, it's brilliant.
Yeah, well, the way the cloud service actually works is that you just log into a version of Octane that synchronizes the files you have locally, and that version has hundreds of GPUs, and you can just tweak the scene or whatever, but you get an instantaneous render, and then we go on to the next customer.
I don't believe you. That's just crazy.
You should come by the booth tomorrow. I mean, if the bandwidth is set up at the NVIDIA booth, we'll show that in a web browser.
Oh,
are you guys doing that? Is that going to be set up tomorrow?
I think everything should be set up.
We tried it yesterday, and I was running the rack, running all the I was using about half the rack because the other half was used by another customer, and yeah, you're getting it's instantaneous. I mean, the noise is, not only do you get the feedback you get, but the noise is just not there, and it's rendering something like 500 million rays a second for these really complex interior scenes, and yeah, that gives you an instantaneous result.
What you're excited about in the road ahead, like what inspires you about the work that you're doing?
Should I start?
Why don't you start first, Bill?
Just being an artist, again, the tech is your friend instead of your enemy, where it's just like the technology keeps up with the artist and it doesn't get in the way and the creativity flows uninhibited. That's a dream state.
I'm in complete agreement with Billy. I have a background as an artist in visual effects as well, and it's interesting that now with tools like Octane, designed for this sort of, you could say, it's future-facing technology. Like nVidia technology was designed primarily for obviously for video games and graphics back in the day. But we've seen that this throughput architecture that it works with is working brilliantly for these massive multi-core systems, many cores, like 2,000 plus cores. And that's the sort of power-friendly way to do things, which is the way we want to do things in the future. So you're riding this wave of technology. So when the software is written to take advantage of that, you sit there and you use it, and it maybe 5 years ago it might be a certain experience, and then more technology just comes out, and suddenly it's a better experience, and then a better experience. And I feel the same with I sort of tinker with things like fluid dynamics and stuff like that as well. And you write something and it might run at 10 frames per second, and then someone goes, oh, we've got a new generation thing here, try that. You stick that in and suddenly it's at 25 frames per second, and then the next generation comes out and it's got more memory and now it runs at 60 frames per second, and it's larger and looks beautiful fidelity and everything like that. So it's like, yeah, technology is sort of pushing us forward in the direction we want to go visually and interactively, and it is so much more fun. That's why I'm with NVIDIA. It's fun.
Yeah.
And we're not going to be able to do our render walks anymore, where we'd set off a render and go have coffee for, an hour or two.
Yeah.
In London, we used to put on the Inferno station, we put a node up that would just say processing, and then we just go to the pub. Sometimes I think that was abused.
It's a revelation for a lot of directors, and I work with a lot of movie directors because they think that, they come to me like, well, I've heard that, you have rendering done instantly and there's no waiting, and as a director I can actually see what's happening, and I was like, yeah, here it is. By the way, here's an iPad and you can play around with it, and it is something that changes the way that artists' work, directors' work. We're just starting getting conversations with movie studios where, how much money gets saved on these films when you can render everything instantly, when the artists can get that feedback instantly. Hard to say, but probably half. I mean, there's a lot of lost hours and time that's just lost because you're just waiting for a render, and then there's tons of iterations and stuff. And a lot of the custom movies are because it's not what you want. You got to go re-render it, and also bringing that. I mean, I think even with Fantastic Four, the goal was to bring something like final render really early in the process during even pre-production. When you have that capability, on the cheap, right? That changes the whole way the movie gets made even later on. So that's very exciting. And then from a technical goal, I mean, we're a GPU company, so my entire goal is to take things that were traditionally serial CPU things like rendering, compression, and bring them into that future-looking GPU world where the parallelism just gives you 100 times the speed. And what's been very exciting this year is when we tried it as a cloud service, even GPUs in the cloud, the way that those things scale, it's very different than CPU render farms, right? So we can build one rack, and it just you don't need 160 GPUs. 70 is plenty to get a noise-free render in real time, and that cost is going to go down by half, I think, every year. So. And so our initial, we announced the service about $1 per hour per GPU, but the thing is, you don't have to wait an hour. You can the time you're just basically borrowing all that time, and you're getting a parallel task done really quickly. So we can do a lot of interesting things in the cloud, and it complements very nicely what we can do locally with just a couple of really high-end modern GPUs, and all of that is an exciting present and even more exciting future, I think.
Well,
can I just add a little bit to that before we go? I think Jules touched on something very interesting, which is the virtual production. That a lot of studios now are starting to think, okay, our production costs are far too high. What if we could do all this? What if we could sort of merge previs with directing? What if the director can be there? That sort of the James Cameron way of the way he wants to do Avatar 2 and things like that. Tools like Octane make it absolutely possible to really see what you're going to get. On the front, assuming that eventually the larger studios start embracing some of these technologies more, because a lot of the time they're sort of setting their long big pipelines, which sadly the industry is establishing might not necessarily be the right way to do things anymore.
Well, and the impact of those long render times and such are industry casualties, rhythm and hues, all the layoffs that have happened so far this summer. So bringing something into the industry, which it just is massively reducing the time involved for creative output is really huge, and it's kind of yet to be seen.
But also, reducing the amount of iterations, the amount of back and forth, as Jules touched on.
Well, I've experienced this on Space Station, where the director has a very specific idea of what we do together. We work on the shots, and it's animatic form to get the shot out as an animatic, but you put lighting in there, and it looks completely different, because a lot of times the animatics are grayscale or just trying to get the animation, and oh yeah, that's great, but then you light it, and it looks completely different, and to be able to do it with lighting very quickly, and that's what the animatic stage is all about, is getting stuff out of there, and get the concept nailed down. But if you throw lighting in there sooner, you'll get there to the end so much faster, because there's no kind of surprises for the director. You know what I mean? Because just getting that all together sooner, I think, is a big time savings.
For sure, definitely. Good. Well, thank you guys for joining us here today. Have a conversation about the state of the union in feature film visual effects. Again, my guests were Jules Urbach of Otoy and Wil Braithwaite. I did take the E out of the titles, and Billy Brooks. Thank you all for joining us this morning.
Thank you.
Thank you.
Thank you.